The postman's name was Fufu, such a funny man. His brother was teacher, but Fufu loved to dance.
Post-transfer applies the deformation from source mesh to a target mesh. Particularly in this paper, we are interested in transferring the pose of a post mesh to deform the target identity mesh. Most traditional studies assume that the paired source and target meshes are existed, with a point-wise correspondence of user-annotated landmarks. To break this limitation, in this paper, we propose a neural post-transfer model, which is using the post mesh and identity mesh directly to fulfill the task without any extra data or knowledge. We use three parameters to represent a human mesh: alpha, beta, and theta. Alpha denotes the parameters of mesh identity, which controls the mesh shape. Beta represents different human posture, and theta indicates the vertices order. Given two meshes, I'm identity, I'm alpha 1, beta 1, theta 1, and I'm pose, I'm alpha 2, beta 2, theta 2. Our goal is to transfer the pose to the identity mesh by producing output mesh, I'm alpha 1, beta 2, theta 1. Our method is invariant to different vertex orders of source and target meshes, and the vertices order of our results are consistent with the identity mesh. Here is the architecture of our network. The whole network is designed as generalizing the style transfer in image domain to deal with points. Firstly, we send the pose mesh into pose feature extractor and get the pose feature. Then we contract it with the identity mesh and send it to the decoder. The decoder is built upon on our SPADA-in rest block, which consists instance normalization and 1D convolution, and can learn the affine parameters in a spatial way. Our training data is using meshes created by SMPL model. For testing, we use SMPL first. The identities are unseen while the pose can be seen or unseen. From the example, we can see that our method can fulfill this task in SMPL dataset. Further, we show the generalization capability of our method. We use meshes from MJ dataset, which the human meshes are very closest. From the result, we can see that our method can deform the identity mesh to various poses with good visual quality. It is worth noting that our model for this is trained using a SMPL dataset, which the human meshes do not bear closest. And we also test it using forced dataset. Our method can still produce good results. Our model produces the correct pose while maintains the geometry details that are not encoded by SMPL, such as the bird. Then, we show the robustness of our method. As can be seen, when given different pose meshes with different identities but same pose, or when given pose meshes with different noise level, our method can produce similar results in the correct pose. Please check our slides and scan the QR code for more information from our project webpage.